Every single day, Bank BRI sends out about 1 trillion rupiah in microloans. That is a massive amount of money moving into the hands of small business owners in just 24 hours. To approve those loans, the bank has to verify the national identities of roughly 500,000 people through the government's Dukcapil system every single day. A few decades ago, this would have required mountains of physical paper. Searching through cramped archive rooms by hand meant that verifying a single customer could take hours or even days. Today, that entire process happens in milliseconds because of a high-speed system designed to link millions of data points at once. We call this database infrastructure. Think of a database like a massive digital filing cabinet that relies on 5 parts: physical servers acting as the cabinet, software keeping folders tidy, network cables allowing remote access, the actual data files, and the people keeping it running. Having data is meaningless if it isn't organized. Without all 5 of these pieces working together, a company's information is just a pile of useless digital noise. Inside that digital filing cabinet, not all folders are shaped the same way. We generally divide them into 2 main styles. This chart showing student IDs and names is a classic relational database. It forces every piece of information into a strict grid of rows and columns. It's the go-to choice for things that need to be exact, like your bank balance or your identity number. But some data doesn't fit into a grid. That's where we use a non-relational database. This is more like a flexible magic box that can hold many different shapes at once. This box is built to hold bulky or unpredictable files, like scanned ID cards, photos, or social media posts, where being able to save things quickly is more important than following a rigid spreadsheet. If a bank uses a loose magic box to store your money, a small data glitch could make your balance literally disappear. But if a social media app tries to shove billions of unique photos into a rigid spreadsheet, the whole app would grind to a halt. Getting this choice right is what allows an app to stay fast as it grows. Imagine a warehouse full of millions of perfectly sorted files. It's useless if you don't have someone who can run inside and find the exact paper you need in the blink of an eye. This is where the librarian comes in. Programs like MySQL act as the active intelligence that handles these static files. This librarian has 3 jobs: translating your search into a digital request, keeping the folders tidy as new files arrive, and making sure the system doesn't crash when 10,000 people all ask for their data at the same time. The librarian is the bridge. It is the only reason raw data on a server can turn into an actual bank statement on your phone screen. When a banking system handles trillions of rupiah every single day, it desperately needs a multi-layered defense to keep malicious hackers out. The first layer is keeping a live mirror of the data. If the main server physically breaks down, the mirror takes over instantly, so no information is lost. The second layer uses a mathematical code to scramble the files. Even if a hacker managed to get inside, they would only see a mess of random symbols that makes no sense. The third layer is a VIP pass system. A bank teller might need to see your balance to help you, but they don't have a badge that lets them see your private medical records. The system checks who is asking and limits what they can see. Without these protections, a single hardware failure can wipe out years of records, and a leaked password can compromise millions of people at once. How does the system at Bank BRI handle 1 trillion rupiah in a single day? They don't just use one type of database. They use both styles to handle different jobs. They use a rigid, grid-like database to track the exact financial numbers where there is no room for error. Meanwhile, they use a flexible database to store the massive files of scanned ID cards and loan documents. The librarian, MySQL, manages both sides. It checks the employee's badge for security, grabs the loan amount, pulls up the scanned ID, and reaches out to the national government servers to verify that the customer is who they say they are. A document search that used to take an employee all morning now happens in the blink of an eye. This efficiency is what allows the bank to serve millions of people safely and accurately. A strong database infrastructure isn't just an IT requirement. It is the invisible engine that allows a modern business to grow and move at the speed of the digital world.